Hello. Salut. Uh, I'm Ethiel Adiassa. I'm a senior software engineer and Google developer expert in Flutter and that. So it's always a pleasure for me uh, to be part of this community and to share some good practices and what's happening inside the Flutter ecosystem. So we're gonna talk about how to design AI native desktop products with Flutter. So AI features are very easy to demo, but building a real AI native product is much harder. So it's not just a matter of a call an LLM API from your user interface. It's about how to design and build a system that can evolve independently. So I'm not going to show how to call an LLM API, but I'm going to show how we can build uh, a strong system that can evolve. So most teams think that when it comes to build an AI native system, they just have to uh, integrate their SDK and wire it into their user interface and call the API. But what happens is that that approach is really fragile and it cannot evolve. So why? Because AI is not a REST API. The AI has first is a stream, so it has a life cycle. It has a life cycle. It also has cancellation. So this is what happens when you wire directly the SDK inside your UI. So you have everything that is tangled and you have a direct coupling between the presentation layer and your infrastructure logic. And your user interface becomes your backend because why? Because you handle the API calls, the parsing, the error handling as well. So your user interface becomes your backend. So why this approach fails in production? It fails because of those reasons. First, your user interface is fragile and is coupled to your uh, your specific AI provider. Let's say you are using Gemini. What if in the future you want to change and switch to uh, OpenAI? You see that there's a strong coupling between your user interface layer and your infrastructure logic. So it's very fragile, and also you are locked to a specific vendor. And if you want to test also your infrastructure, it becomes very hard to test because there's no coupling, there's no contract. And what I want uh, to to tell is that we want to shift our mindset from just build a feature, just from shift our mindset from building an AI feature to building an AI capability. So we don't have to wire our user interface into a model, but we want to build an AI capability layer that can evolve independently and without breaking our core system. So the principle I want to enforce is that we should build and engineer for volatility. That means that uh, your your domain and your business logic is permanent, but AI is fragile. AI is volatile, and also the the concerns of your AI implementation should not be coupled into your, for instance, your presentation layer and so on. So we want to design and engineer for volatility, and we want to isolate what changes constantly from what is permanent. So that said, we want to isolate our domain logic from our infrastructure logic. So when it comes to Flutter, we have the state management, also called state orchestrators. So the state orchestrator should be responsible to handle the state and the time. And your AI infrastructure should only be responsible for handling the what I call the intelligence. So we will dive into it deeper. So in this talk, we will focus on a case study, Lossless Clip Desktop, and we'll see how Lossless Clip applies these architectural principles to handle complex clipboard data, like explain, summarize, translate. So this is the blueprint here. So inside Lossless Clip, I have those layers. I have first a clipboard AI panel. That is the interact point between the app and my users. So users interact with the clipboard AI panel to perform a set of actions, like I've said before, explain, summarize, translate. Now I have my clipboard detail qubit. So this is my orchestrator, my state management here. Clipboard detail qubit. So it manages the life cycle of an AI response. Now I have a clipboard AI facade. The facade maps the intent from the user to uh, to an AI action. Now I have an AI test service that does uh, the AI test service creates a kind of strict boundary, and it creates a contract that all my LLM providers should follow, should implement. And now, finally, I have the mini AI test service that provides the intelligence. So now we have the domain intent. Let me show it. Okay, so as you can see here, I have the explain, the summarize, and the translate. So the domain intent here is to find a way to translate those user interface actions into a domain intent. So here, this is translated into an AI test action here. So the AI test action is either an explanation, a translation, or a summary. So I have to model that into a clear domain intent. And also here, this is really critical, because here, the AI test service returns a stream, because the AI response is not just a simple response, but is a sequence of tokens. So it has to be a stream. And here, this is the request here, the AI test request that encapsulates what the user wants to perform. And I've also have the clipboard AI facade. The facade is like a shield. It's like a boundary that protects my state orchestrator to contain some AI um, computations, some AI logics. So that's what the clipboard AI facade does, and it exposes this method, the perform action method here. And finally here, I have my orchestrator, the clipboard detailed qubit that handles the stream lifecycle, the stream cancellation, and also it holds an active stream subscription. So why do we need a stream? We need a stream because, as I've said before, the response coming from the LLM is not uh, a simple response. So we cannot await that. Technically, we can await that, but it will block the user interface. So a better solution is to just uh, render the response as it comes. So we we are not blocking the user interface, but we are render the response as it comes to the user interface, and it will be displayed to the user. So let me show you a demo, because everything I've discussed so far is not just pure. It's not just pure theory, but it's running in a real product. So okay, you'll see my screen. Let's say I have this, and I will copy this. So let me just run it here. So okay, what I've just copied is here, and I want to explain it, or maybe summarize it or translate it. Yeah, so I want to translate into French. So here this is handled by my state orchestrator here, and you've seen that the response has been streamed. The response has been streamed here. So technically, I have an AI test action here. So just this models the user intent, explain, summarize, or translate. Now I have this AI test request here. So I can have an explain test request here, a summarize test request, or a translate test request here. Now, let me go to the AI test service. So this is my contract, the AI test service. So this defines a contract that all my future LLM providers should implement, and this removes the burden from my state orchestrator. So inside the Gemini test service here, I'm doing the real job here. The real job is done here. First, I pull the so I'm using Firebase AI logic here. So I pull it from here, and inside the generate method, I've I'm building my my prompt here. So explain the following text in simple, clear terms, and so on. Summarize, translate, and here I've given it a clear role. You are helpful and expert assistant that performs and blah 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 blah. And here we are streaming the response as it comes. So it's a stream here. So when an error occurs, I add the error to my stream controller, and everything is streamed. And the clipboard AI facade acts like a boundary, like a shield between my state orchestrator and the AI test service. So the facade implementation is here. So simply it maps the user interface actions and intents into a clear domain intent here. So if the user wants to perform an explanation, I grab it from here and I create a request. So if it's an action, if it's an explanation, I create an explanation request and so on. And finally here inside the qubit, so the qubit here is my state orchestrator, my state management, and it has a dependency on the clipboard AI facade here, and perform summarize here. So when the user clicks on the summary button here, the state management calls the clipboard AI facade, which call the perform action method here. And finally, at the user interface layer, at the presentation layer, I have the clipboard AI panel, which adds like a dumb, a dumb, a dumb renderer. So it does not know how I'm handling the AI intelligence. So it's a pure presenter. So it just presents what comes from the AI. Let me show you here. Yes, this is the AI. No, the AI result. No. Yeah, the AI result card is here. So this is the AI result here. So it's a string here, and what I've done is simply when I get the response from the AI, I show it inside a test box here. And if an error occurs, it's also handled fine, because I have like inside my state orchestrator, I have something that handles the state transition from loading to. Let me show you that. This is a pattern I use for all my apps. So I have this value wrapper that handles the state transition from like loading, success, error, or initial. So here, if I have an error, I simply show this, or if there's no error, I show the AI result here. So let me do another. I think I have. So I will ask him to summarize this. Yeah. So this is the result, and it's as I've said before, the presentation is just a presenter. It doesn't know how the AI is handling the logic. So when, for instance, I'm performing is is a summary and the user close the panels, I have to cancel the stream immediately to not leak uh, some memory. So close the if I close the panel, the the stream is automatically canceled and closed. So let me go back to the here. So this is a future-proof architecture because if I want to switch from a cloud provider to a local provider, I just have to I just have to create another service uh, that will simply implement my AI test service. So I will not modify anything inside the presentation layer. So only inside my infrastructure. So if you have to remember three things, here they are. So first, we have to build some AI capabilities, not simple features. So we don't have to, we shouldn't wire our user interface directly into a modal API. Then we also have to separate our intelligence from the time. So by intelligence, I mean all the AI infrastructure, and from the time is your state orchestrator. And finally, we should engineer for uh, volatility. So that means that your domain contains your business logic, your business rules, and that's what matters most to you. And you should protect it from anything that is volatile. So anything that extends to you, like an API, and in our case is uh, the LLM API. So this ensure that we can we can easily swap from a cloud provider to a local provider. So AI models will change, but your architecture shouldn't have to. Yeah, thank you.
I have a question.
Yeah.
Can you bring the AI interface?
Okay.
Code?
This one.
Yeah. What did you mention about like if I want to, for example, Gemini to ChatGPT, how do you do that?
Okay. Okay. If I want to swap from instance from Gemini to ChatGPT, so let's see, I will create here ChatGPT service, implement AI test service here. So, and inside the build prompt, let me the build prompt here. I'll copy this. So here I will perform my actual API call here. So now, if I want to swap from the Gemini AI test service from the ChatGPT, I want to swap the Gemini to use the ChatGPT service inside my infrastructure. Here I will let me go here. I'm using yes, I'm using injectable to provide the dependency. So here I will remove it here and put it here. Yes, yes. Yes, I can also provide some. Yes, I think it has a name here. Yes. Yeah. Yes, sorry. Yes. So I can give him some name here. Gemini. And after after that, I will have uh, to uh, to to generate the dependency once again. I don't remember the yes here.
You mentioned from swapping to local to the cloud, it needs to stay in the OpenAI type of spec. Because if you use local models, often like the API is a bit different depending on what model.
Yes. It's true that the API is different, but with this architecture, everything related to the AI logic will not impact the yes. So yes, it's actually the service and the actual call will be handled here, and the the state management only calls this this perform action. So everything is hidden and encapsulated. So so do you have more questions?
Was it the better for you to see this kind of architecture using the interface and the different implementation?
The maximum architecture.
No.
Yeah.
What's called architecture. Maybe I will get.
Yes.
Actually, I haven't used that.
Okay.
Where does it actually visualize?
Okay. Yes, is automatic. Uh, yes, when I start the app inside my bootstrap method, I have it here. Yes. Before the run up, I have this method configure dependencies. See, so this, yes, yes. So here, get it dot init, and it handle the injection here, so automatically.
I don't like it.
Ah,
I mean,
yeah, yeah, yes, perfect.
If you use get it, it's better to use it. Otherwise, you're gonna
I
like,
mean,
have like
it destroyed the whole architecture. Get it? You can access get it from everywhere. So
No,
yeah, it's not the
sorry,
it's not the purpose of getting
you
to
can
get access to it.
you can hit your but everyone uses it like that. Unfortunately,
uh,
I'm not who decided to give an architecture, but if the library let the people to misbehave the library, yes, I don't like it.
yeah.
But block doesn't let you do that. Block it's very
so just again, I think you're confusing with get X.
No, 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 no.
no, no. I'm talking about get it exactly.
Because
Because
you
you-
then block it. Completely.
It's not the same. No, no. I mean the way that it doesn't let you to do everything with the package, you know, with the library. But get it in. I mean, in my company we use it a lot, and we use it as a misusation.
It's your company.
yeah, it's the company problem.
No, I mean, it doesn't depend on the company. It depends on the people who was previously used it.
There's another thing actually more common. I thought that actually your initial the AI prompt before it actually stream
Yes.
takes a long time. I noticed. I think it's because you didn't set the thinking button.
Please.
Thinking button.
Okay, 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 okay.
You just remove the thinking part,
Yeah.
then it's going to show up.
Can you reduce the thinking part or just remove it?
Yeah, by default, the Flash point 5 has the thinking button. If you don't disable it explicitly, then it think inside.
Yeah, yeah,
And
yeah.
that's the way you can screen the thinking, but you don't need it actually. You only need to summarize and translate. So
Okay, yeah.
disable it, it's going to be much better.
How do you disable it? It's in
I don't remember exactly, but I think there's somewhere the five
In
APA.
the configuration.
Yes, maybe here. No, no, it's not here. Okay, thinking config. Okay. Okay, so uh, I'll I'll I will change it later because it will take time.
I had the exact same issue in my app, that's why I know.
I got thinking objects. Oh.
and cost more.
Hmm?
And it
You
costs
got
more.
left because you are disabling the thinking.
No, no, no. I mean, if you
You think
Yeah,
yes.
yeah.
Okay, thinking level.
maybe it's they did it on purpose.
Unfortunately, it's complicated. You need to implement the thinking streaming part. Otherwise, it's going to be just pending.
Yeah, well, that's what we've seen. Like, it kind of loaded for a while, and then it streams to
Exactly. I was wondering why.
Yeah, 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 yes.
But there was
because thinking is basically just a
Okay, I think if I've change it to low.
We have 4 minutes.
4 minutes. Okay, so I'm done. I'm done. I'm done. But I don't know if I have to. Yes. But, let me remove this first.
or you can implement the offline AI with my life.
One feature you can add like to store the prompt and make your prompt better.
Yeah.
Ask AI to make it better, not to use a static prompt.
Okay.
You know what I'm saying?
No. Can you explain it, please?
Like, for example, you can add a feature that save the and make it better. Like,
Oh, okay.
training the
Okay.
data.
Yeah. Yes. I got it. Okay. So thank you for your attention.
So we have like 15, 10,
15 minutes.
yeah, 15-minute break.